Um, so today I'd like to introduce Dr. Ari Antonovsky. There we go. See, I've practiced. He's at the Applied Human Factors at the Uni of WA. Dr. Ari is originally trained as a materials engineer and then morphed into a maintenance and reliability engineer through working in the mining and petroleum industries out here in Australia. Indeed, he and I were having good chats and all that sort of stuff afterwards. And also here in PNG in Indonesia. His consulting work with maintenance crew convinced him of the importance of human and organisational factors in keeping organisations running efficiently. This has led to a PhD at Curtin Uni involving human factors in maintenance reliability. And during the last 5 years, he's been a senior research fellow at UWA working on a range of human factors projects for the Australian Navy.
Okay, so I think it's very important that we have forums like this. It's very pleasing to see that the resource industry is, in a sense, finally coming of age and finally embracing human factors. So that's incredibly good, and good to see so many people attending this. But the question I'd like to pose is, how can we tell what's important? The human factors field, as you've started to gather from what Justine and Zoe have said, is quite a broad field. There are a lot of issues there. And particularly in the field of maintenance, which has been my area, the question always is, well, what's important? What do we need to focus on? So towards that, I'd like to talk a bit about answering that question, potentially this morning, about the role of human factors in our complex systems. So what sorts of things we need to know about that, how we might identify the human factors that are important, particularly in terms of effectiveness in maintenance and operations. I'd like to talk about some of the techniques that I've used, which what I'd call mixed methods, essentially using a combination of qualitative and quantitative data to find out what's really going on. I'll give some examples of the use of this that have been from my background in the resource industry. And finally, some of the learnings we might take away from this that might be useful in terms of interventions to improve our maintenance effectiveness. Okay, but I'd like to start with a real life story first, which tends to give us at least some idea of the importance of human factors, even in very small matters. So there's a story that appeared in the paper a few years ago about a key from the Titanic that was up for auction. And the reason it was up for auction was it never sailed with the Titanic. It was in the pocket of an officer who was transferred away from the ship before it sailed. So they didn't have the key to the binoculars cupboard when the ship was approaching the field of icebergs. Now, being good British sailors, of course, they weren't going to break into the binoculars cupboard to get them, so they had to do without. Ended up striking an iceberg. The rest is history, as they say. But it's an excellent example of how even a small matter like a system to make sure that a key goes with the ship and not off with somebody who isn't on the ship can make a huge difference, in this case, impacting the 1,500 lives that were lost. So I think that's a reminder that we have to work on a systems basis, and Steve alluded to that. It's our systems that really are fundamentally important. A little bit more broadly speaking, in terms of some interesting facts on human factors in industry, a study was done on the Japanese and American nuclear power industries, and they found that roughly 50 to 70% of failures were due to human error and various other human factors. Now, even if that's slightly exaggerated, it's still a very high figure and shows that at the end of the day, in heavy industry, this is going to be an incredibly important issue. Of course, anybody in the room who's familiar with the oil and gas industry would know about Piper Alpha, unless you've been asleep for the last 20 years. And we all know that that disaster resulted in 167 lives lost and about $3.5 billion in losses. And the analysis that was done on this basically showed that combination of human error, poor decision-making, poor maintenance, lack of supervision, all of these being classic human factors. It's not all bad news, as Zoe said, there's good news and bad news. So the good news in this one is that they looked at human factors at the front-end engineering design stage of an oil and gas installation in the US. And they found that by focusing this at the design stage, they're able to reduce the number of design changes at the installation and commissioning stage by a factor of 10. And for those of you who work in the design and construction of oil and gas installations will know that this represents an incredibly huge savings at the end of the day. And something that we all tend to forget, but really is important to mention, is that the modern technologies that we have the potential to magnify hugely the impacts of human factors on operations. So I picked out one example. There are many, many examples, but the one I like is actually from the finance industry. We have the Barings Bank collapse, happened a few years ago. Now, this was an organization that stood on its feet for 233 years, but it only took the actions of one person in the space of a couple of months to bring this to its knees with $1.3 billion worth of losses. So this would have been impossible a generation ago, but modern technologies obviously have the power to magnify what single human beings do. Okay, so why does this happen? And one of the reasons it happens is because the very often gaps between these lovely engineering designs that look terrific on paper that we've worked on for months and years, and the results they have when they hit the organizations and the humans in the context that they have to work in. So we find that basically these gaps always exist. They're always going to be there, and it's something that we've got to work with, something we've got to acknowledge, and that tends to be where human factors comes in. So human factors is essentially about aligning the capabilities that people have, but also their limitations, and also working with the context that they're going to work in to make that align with the work that they're going to do. And if these things don't align, this is where our failures are going to occur. Now, there's another issue which was alluded to a bit earlier. It's lost part of my picture. Oh dear. Okay, this is the problem with giving things over. There's a little box around the reliable zone. And the idea there is that with any engineering design, you've got an area of reliability, a zone where it was designed to work in, and that tends to give you reliable outcomes. Now, due to various drifts within the organization or pressures within the organization, these can be financial pressures, time pressures, maintenance pressures, management decisions, we have drift out of that reliable zone. And this is a topic that Sidney Decker's picked up on, that Jens Rasmussen has picked up on, that this is going to happen just because of the way that we work. And it doesn't just apply to one particular area. We find that can apply to workplace conditions, for example. So we heard from Justine about that workplace conditions, unless you're on top of things, things would tend to drift out of your control. Same thing with technical factors such as aging of equipment or buying fewer parts or doing less maintenance. Again, that drift out of the reliable zone just increases your probability of failure. And of course, we can't leave out the humans. So human actions, if there's complacency, if there's lack of training and lack of understanding, those actions are going to drift us out of there. And these probabilities tend to overlap. And as we know, if we start to overlap probabilities of failure, you will increase the overall chance of failure. So how do we counter that? Well, part of the way we counter that is to start to understand at least the importance of the maintenance function. The maintenance function isn't just about coming in, changing a few parts, doing a quick fix. It actually supports these socio-technical systems. And Steve mentioned that very briefly, that it's the maintainers, that the people that we rely on very often keep these systems going. Because we have these gaps, because systems tend to drift, because things go wrong, maintenance people are there, and they're the ones often understanding the equipment well enough to know when things are not right, and often getting things back on track. So they're often the ones that close the gap between the designs and also operations, because we know that typically production pressures push operations to areas that they weren't designed to do. It's very often maintenance that comes in and picks up those pieces. And finally, it's often maintenance that deals with the interactive complexity of the systems that we'll work with. And by interactive complexity, what we mean is that very often systems become so complicated that we actually don't understand what the impact of a change in one part of a system, such as ramping up production in a particular area, will have on other aspects of the system. And it's very often the maintenance people who can tell you exactly why this is happening, why something may be going wrong just because you've tweaked the system a little bit. So we have to come back to them often to understand why these things are occurring. But sadly, it's a very unexplored area of maintenance. If you do a Google search of papers on maintenance, you'll find a very, very small number of people investigating this area. And there are a number of reasons for it. Of course, we always have that focus on technology, so we don't focus so much on the people and what they're doing. There's also tends to be an incorrect view that maintainers are working from procedures, working from a cookbook, and that really there's not a lot of thinking that goes into what they do. They don't have a lot of autonomy. There's not the complexity. They're just basically following a procedure. And at the end of the day, they should be, if they did what they were told, if they did what followed the procedure, there wouldn't be a problem. And this is a very incorrect view because we know that often the procedures aren't right and often the potential for things to go wrong is not built into what we do, what we proceduralize. And there's also one final factor which I've seen operate, but it's a bit more of an intangible one, and that's that the maintenance function of the maintainers tend to be the poor cousins to operations and certainly to maintenance, to engineering, and we regard it as a low socioeconomic status job, that basically they're not people, these are people work with their hands, they don't have brains, they're not worth talking to. Why would we ask them what's going on? And I think that's always a very dangerous place to be. So how do we get at this information? How do we find out, how do we capture the human factors information that's out there so that we know what sort of interventions to put into place? And of course, we've got our failure reports. We've talked about that quite a bit this morning, a root cause analysis. But in the work that I've done, and Steve's alluded to it, in the Navy particularly, and I hope that doesn't go outside this room, I've looked at many of their reports, and there's almost no human factors content. It's almost all technical content. So there's often very little to work with in that realm. You can look, if you've got a human factors person within the organization, they can start to look at reliability engineering data and link that up with any human factors data, such as systems that are put into place. But again, you need the people within the organization that are working in that space. So very often I've found in the work that I've done, the best and sometimes the only way to get at this sort of information is to actually speak to the people that work in these systems day in and day out. And certainly Zoe's shaking her head and saying, yes, that's definitely what we've found as well. So to do that, what I'm going to do is propagate or discuss a mixed method approach, which is basically a combine using qualitative data with quantitative data. So we tend to focus very much on the KPIs and the quantitative data, the survey data, but now I'm going to introduce the idea that there's also a lot of qualitative data that we could be using. So just to give you some ideas from people that have worked in these systems that are focused on the qualitative and the organizational, Bourrier, who's done a lot of work with nuclear power plants in France and the US, said that essentially we have to design and understand the organizational structure of a system at the exact same time that we're developing the technical systems. You can't put into place a technical system and then come back a year or two later and say, oh, maybe we should have thought about organizational issues. Ryman, in his work on assessment of complex socio-technical systems, and that's a word you'll probably hear a lot today, says they're basically socially constructed and dynamic cultures. So essentially, we rely very much on the social network of people within an organization to keep it running. And these things aren't static, they keep changing over time. So if we want to understand them, we've got to look at those social issues, we've got to look at the dynamics of what's going on. And finally, Decker, who again is somebody I think that we all need to look at because he's got amazing ideas in this realm, says that to do this, we need to gather multiple narratives. And not just a single story, but essentially many stories from the different people that work in different parts of the organization to try and understand how this complex system actually ticks. So what I'll talk about now is some of the investigations I've done with mixed methods. Putting it forward is essentially a toolkit that we need to have. So we heard about toolkits before. So this is another toolkit. We're trying to use both subjective, so-called subjective, and objective measures to get at the information that's out there. Now, I use those terms advisedly because at the end of the day, any interpretation, any analysis that we do has a subjective component. There's always bias. There's always ideas that we come to that are preconceived before we start. So all information is going to be subject to these factors. But essentially, with the quantitative data that we're gathering, the KPIs, the surveys, we're finding out what is actually happening out there. But with the qualitative data, we're trying to understand how it's happening and why it's happening. And one of the main reasons we do this is something called triangulation. We want to have several sources of information to make sure that what we're learning is actually genuine. So we're not focusing on one particular factor that may be leading us down the garden path. We want to make sure that our understanding is fairly complete. It also means that the things that we're measuring, if we use qualitative measures, we have the opportunity to find out what else might be happening that we might not have thought of. So with a lot of KPIs, they're very definite sort of measures. They tell you very definite information, but sometimes they're not actually measuring what we need to know. And we get very hung up on the KPIs. It's sometimes important to step back and say, well, what is it we're not measuring? What is it we're not thinking about? So I'd like to put forward the idea of a combined qualitative, quantitative approach, which I liken to the peeling away the layers of the onion. As we go down this path, we find that we're learning more and more about what's at the core of the system. Okay, so now what I'd like to do is talk a little bit about some of the examples that, from my work experience, some of the things that I've done that actually use these sort of techniques to show you how they might reveal information that might be difficult to get at in any other way. So this was a what I called a delay time study. Most of you would be familiar with the concept of tool time, where you're measuring what percentage of time a maintainer might be out in the fields, swinging a spanner and finding out what's wrong with a piece of equipment. So delay time is the converse of that, how much time they're delayed or stopped from actually doing that. And in this case, the company had tool time figures of about 30 to 40%, which they were frankly horrified about, and wanted to know where all the time was going that was not spent fixing equipment. So to collect this data, initially spoke to engineers and managers in a sort of interview environment to get at some idea of what they thought were potential contributors to delay time. And that resulted in a little docket, a pad of dockets that maintainers could carry around in their shirt pocket. And every time they were stopped from doing a job, they'd write down what the cause of the delay was and how much time was involved, and maybe some other details that we needed to know. And through that, collected a lot of quantitative data now. And that told us where the time was being lost and gave us ability to construct a Pareto chart of where most of the major time wasters were. And I use the word time wasters advisedly because the top one would be permits, and we all know the importance of permits. But then the question is, why is so much time being lost due to permits? And that brings us to the next stage, which is qualitative interviews with groups of maintainers, sort of a focus group. Why is permitting such a problem? Why are meetings taking so much time? Why is transport an issue, et cetera, et cetera? This is all very unique to that particular organization. But through this process, we found very clearly where the holdups were, where the problems were. We had the quantitative data. We could then go back to management and say, these are some of the interventions you need to put into place, and it should make a big impact on your loss of time, you improve your tool time. The second investigation was one into operational failures, what the human factors contributors were to operational failures in this particular organization. Initially, we thought we could get at that information through their incident management tool or their incident recording database. There were about 1,000 different entries into that, so we're talking about a vast quantity of data. To do that, we used the human factors investigation tool. This was developed by the University of Aberdeen for their work in the North Sea oil and gas. So it was fairly appropriate for what we were trying to do. And it encompasses about 27 fairly standard human factors: decision-making, omissions, communication, all those sorts of things. And we use that to analyze the entries in the database. Now, unfortunately, the database really didn't have a lot of human factors data. And this comes back to the problem of not having human factors trained or human factors expert people doing the investigations. So again, a lot of it was very technical, but we did come up with a few interesting things, namely that the people doing the investigations mainly blamed rule violations for all the failures. That's probably not going to be a surprise to most people, but that's what we found. Design, so human factors in design, where the designs had let them down, was the second most common one. And then lack of situation awareness. So we've heard that from Steve, people weren't aware of what was going on around them. Even at this sort of level of human factors investigation, there's still a mean of 2.3 factors per incident. So there's a bit of complexity even at this level. But we weren't satisfied with the results we're getting. So what we did instead was constructed a semi-structured interview around the human factors investigation tool. And we asked maintainers to tell us about an incident that they were actually personally aware of, firsthand aware of, or experienced. And we went through the human factors that might apply to it. And in the end, got much more detailed information. And interestingly enough, assumptions was the number one cause of failures that they were involved in. So these were assumptions about what work had been done, what had been wrong, whether the right part was there, where the cause of the failure was, various sorts of assumptions. Human factors in design and maintenance was number 2. That was interesting, came up number 2 a second time. But for anybody involved in modern organizations, communication was number 3. No surprises there. But I think what was most interesting was that now when you go a deep dive into what the causes of these failures were, we now had a mean of almost 10 different factors that contributed to these failures. So we start to see the complexity of things going wrong within a system. Now, this was over about 40 different incidents that we investigated. So it was a sizable sort of study, but not as much as we would have liked to have done. So that brought us to the next investigation that we did, which was basically to do a survey across all of the maintenance personnel. And the idea was to take these top hitters, these heavy hitters in terms of causes of failure, put them into a survey, and then survey the maintenance workforce as to what they thought were the main issues that they were dealing with. So the survey looked something like that, and then questions along the lines of thinking of the machines and equipment you're working with. Are essentially they fit for purpose, et cetera, et cetera. And we analyzed the data on the basis of the reliability level of the different facilities that were within the organization. So there were lower reliability, medium reliability, and high reliability facilities within the same organization. And of course, some interesting results on that. They were statistically significant. So, for example, on the design and maintenance data that we got, it was pretty clear that as you go from the lowest reliability to highest reliability, the attitude people had towards the quality in terms of design and maintenance improved. So not too many surprises there, but it was good to see that at least when we queried people, there was actually an association between their attitudes towards the equipment they worked with and actual reliability levels on a statistical basis. What was a bit of a surprise was with the questions to do with problem solving, and this relates back to assumptions, we found a reverse effect that as you go to the higher reliability facilities, people had less involvement with problem solving. The problem solving tended to be higher in the lower reliability facilities. So when you think about it, that makes sense. When you put the two together, you come up with a conclusion that if you get your design correct at the start of a facility, at the construction of a facility, you'll need far less problem-solving skills amongst your workforce as time goes on. If, on the other hand, your designs are not human factors focused, then you better have a workforce that knows how to solve problems. Otherwise, you're going to have low reliability. Now, one of the other surprises with it was that there was no significant differences observed in the communication statistics. So we thought that was a bit strange, given that communication played such a big role in the failures that the organization had experienced. So for that, we fortunately had one qualitative question at the end of this long multi-choice survey, and that was almost a throwaway line. It was just something we threw in. I threw in at the end just in case there was something we missed, which clearly there was. It just said, please write down anything that might get in the way of maintenance work at your company, along the lines of something that Zoe had said. And frankly, didn't expect very much. I was still a bit naive and thought that, well, these guys aren't going to have much to say. Well, in fact, it was completely the opposite. There were 100 different written comments, some of them sarcastic, some of them vents, but most of them actually very perceptive about what was going on in maintenance in the organization. And so much so that I ended up doing qualitative analysis, what we call a thematic analysis. So looking at the themes inherent in the comments that we're making and trying to group those comments together under a thematic heading. And in the end came up with 4 different themes, essentially. So communication, access to information, efficiency of work systems, need for more personnel and support, and management and supervisory impacts. And what we learned from this was interesting. So the higher reliability facilities, most of the comments related to how they could make the systems work more efficiently. So in general, they were happy with things, but things could always be improved. On the lower reliability facilities, we found that they were basically blaming management and supervisors for things going wrong. So here they were working on poorly performing facilities, and they sheeted that blame home to management. With communication, on the other hand, it was almost across the board. So what we came to the conclusion of that was that this was essentially a company-wide phenomenon. You couldn't attribute it to a specific facility. Essentially, everybody in that company were working at the same level of issues to do with communication. And in fact, we had confirmation of that because when we compared contractor data to company employee data, there was a very big difference between the two. So it was a company level issue rather than a facility level issue. So through all that, we found that there was a lot that we could learn just by going back and forth between this quantitative data and qualitative data that we can collect from the workforce. So just to wrap up with a few of my thoughts and a few of the learnings, I'll reinforce the fact that although maintenance seems to be a technical function, seems to be controlled by sort of procedures, cookbook style, in fact, the human factors are a huge influence on the work that maintainers do. The organizational issues are important. And so we have to get away from this idea that it's all technical and start to look at the organization. And that when we talk about human factors, it's not this amorphous sort of mass of issues, that there are specific issues that are specific to a workplace, specific to an organization or company. And so we have to identify what those specific issues are. As Zoe said, we can't fix everything. So we have to know what it is that are the most important issues and try and focus interventions on those. So organizations need to understand not only what those issues are, but what impact they're having. And then another issue, of course, as I've hopped on here, but I'll reinforce it here again, is that there's much to be learned from the workforce. These are the people that work with it day in, day out. Some of them have years or even decades of experience, know what to look for, know what's going on. And so if we want that sort of almost leading data rather than lagging data, these are the people that are almost going to tell you what's going to happen next. So, and I'll reinforce the fact that in a lot of cases, this is information that you can't get from anywhere else. And finally, surveys and KPIs and various quantitative data often tell us what's happening. That's incredibly important. We need to know what's happening. But at the end of the day, we also need to know how it's happening and more importantly, why it's happening if we're going to put in the right interventions. So it's the qualitative data, the interviews, the group focus sessions that are going to tell us that. And that's what we need to do as well. So we're using our qualitative methods to want to confirm or clarify some of the findings that we've got from the KPI data, but also we're using it to get a bit closer to the world that these people in maintenance inhabit and understand a bit more about what they're up against day by day. So that's my message. Thank you.
Thanks heaps for that, Ari. You know, it's one of those things that, as Ari said, being consulting, and prior to my time at the department, I was a reliability consultant, the same as Ari. And we used to make money out of that. It was, you know, you'd rock into an organisation and we had basically nothing to do in terms of talking about the actual pieces of equipment and reliability. It was all about human factors. And it was all about trying to understand what the workforce were actually doing. I remember one particular major company that I did some work with, just by changing the way the maintenance instructions were written to improve the reliability of the people. And we got that feedback from the people themselves so they could understand what they were actually doing in terms of, we actually saved the company about 20% of their operational budget. So as a consultant, that was awesome because that meant we stayed there for about 5-6 years, doing a lot more work and making more money. But it actually affects your bottom line directly. It's not just something that sounds really cool and looks, you know, we tick the safety box and all that sort of stuff. This is something that you can actually sell to your the powers that be as being something that you can save a lot of money by just thinking about this sort of stuff.